Hello students, today we will discuss about midpoint theorem. Its statement is like that the line segment joining midpoints of any two sides of a triangle is parallel to the third side and half of it. So the portion of the statement before this line is treated as given while writing the proof of this midpoint theorem. That is, the line segment joining midpoints of any two sides of a triangle. It is given to us. So we will write in given part a triangle, say ABC, in which midpoint of AB is D and midpoint of AC is E, and DE are joined. This line segment is given. So in given part we will write a triangle, say ABC, and D, E are midpoints of the sides AB and AC respectively. Also DE is joined. Now portion of the statement after this line is treated as to prove. So is parallel to the third side and half of it. Is means that line segment is referred here for that line segment which joins the midpoint of any two sides. So to prove, we have to prove DE is parallel to BC and DE is half of BC. So in to prove part, we have to write DE is parallel to BC and DE is half of BC. Now what we have to construct here to prove this theorem? In construction part, we have to produce DE to a point F such that DE is equal to EF, and FC is to be joined. This is construction, and we have to label some angles as shown in figure. This is angle 1, this is angle 2, this angle is number 3, and this is number 4. In construction part, we will write we produce DE to a point F such that DE is equal to EF, and label some angles as shown in figure. Now in proof part, we are starting to prove this theorem. Now consider triangle ADE and CFE. We will show that these triangles are congruent. So in triangle ADE and triangle CFE, firstly DE is equal to FE. DE is equal to FE. Reason behind this is construction. Second, angle 1 is equal to angle 2. This angle 1 is equal to angle 2. Why? Because it is a pair of vertically opposite angles. Then AE is equal to CE. AE is equal to CE. Why? Because E is midpoint of AC. E is midpoint of AC. So we have here D is equal to FE, angle 1 is equal to angle 2, and A is equal to C. Therefore here side angle side congruency is applicable. Side angle side, this side is equal to this. Therefore triangle ADE is congruent to triangle CFE. ADE is congruent to CFE. Name of the first triangle we can write in any order. These letters. Every vertex of the second triangle should be written in place of corresponding vertex of the first triangle. So these triangles are congruent. Why? Because we used SAS congruence rule or criterion. Now because these triangles are congruent, therefore their corresponding parts will be equal. So AD will be equal to CF. AD is equal to CF. Reason CP CT, because corresponding parts of congruent triangles are equal. But AD is already equal to DB, because D is midpoint of AB. D is midpoint of AB. Now see, in these two equations left hand sides are equal, so the right hand side must be equal, or in other words we can say DB and CFC, DB and CF both are equal to AD, so they must be equal to each other. Gives that CF is equal to DB, or we can write FC is equal to DB. Now see, angle 3 and angle 4 are corresponding angles of these congruent triangles, so they will also be equal. So angle 3 is equal to angle 4. Why? Because these are corresponding parts of congruent triangles. For triangle ADE congruent to triangle CFE, so these angles are equal, but these angle 3 and angle 4 form a pair of alternate interior angles. 4 lines AB comma FC and transversal DF. But these angles forms a pair of alternate interior angles for lines AB, this AB and FC, AB comma CF, AB comma FC, and transversal DF. And we know whenever alternate interior angles are equal, then lines must be parallel. So AB is parallel to FC. AB is parallel to FC. Now because DB is a part of AB, so DB must be parallel to FC. Gives that DB is parallel to FC because DB is a part of AB. Now see, this is statement number 1 and this is statement number 2. From 1 and 2 we have DB is equal to FC. This is DB is equal to FC, and here DB is parallel to FC. DB is parallel to FC. Therefore, quadrilateral BCFD. Quadrilateral BCFD. In this quadrilateral, DB is parallel to FC and DB is equal to FC. So here a pair of opposite sides is parallel as well as equal. So this quadrilateral must be a parallelogram, or this quadrilateral will be a parallelogram. Therefore quadrilateral BCFD is a parallelogram. Why? Because a pair of opposite sides of it is equal as well as parallel. Now see, in this quadrilateral BCFD, this becomes a parallelogram. So its another pair of opposite sides will also be parallel and equal. So we can write DF is parallel to BC and DF is equal to BC. Gives that DF is parallel to BC and DF is equal to BC. Why? Because opposite sides, these are opposite sides of a parallelogram. So these are parallel and equal. Now as DF is parallel to BC, DE will also be parallel to BC because DE is a part of DF. Gives that DE is parallel to BC, and DF is double of DE because we constructed DE equal to EF. So we can write DF is equal to double of DE. So here we will write double of DE in place of DF. So double of DE is equal to BC. Gives that DE is parallel to BC, that is as it is. And now divide this 2 in right hand side, we will have DE is equal to half of BC. So what we obtained here, DE is parallel to BC and DE is half of BC. This is what we had to prove. See here it is written in to prove part, DE parallel BC and DE equal to half of BC. Any corrective suggestions regarding this video would be welcome. Thanks.